So today we're going to talk about probability here and think about the probability from its name. Might be probability here, but we can turn this into mathematical calculations here. So how to do this? How to turn probability into mathematical calculation? For example here, if look to this one, telling you probability of any event, whatever the event, equal number of ways that event can happen divided by total number of possible outcomes. What does it mean here? Imagine that we have a dice, for example, here, dice here, and let's draw this dice now here. So this dice here, if we have this one 3 and this one 2, for example, and this is 1. So dice, this dice, any dice have 6 sides, isn't it? 6 sides. So if I ask you what is the probability, and this is going to be the event, probability of you, if you threw this dice and you got number 3, for example. So if you look here, we have only one side has 3, right? So how to write probability of having 3 telling you equal number of ways that event can happen. It's only one side only. One side only can make 3 happen. So it's 1 divided by total number of possible outcomes. If you throw the dice might come into 1, 2, 3, 4, 5. So it's 6 possible outcomes. 6 possible outcomes. So that's mean total number, it's 6 possible outcomes. So the probability of having 3 for this dice is 1 over 6. So that's how to get the probability of any event. And if you look here, it always, probability always between 0 and 1. 0 means no way to this happened, and 1 this is a certain gonna be happened. And you could write probability in decimal, percentage, or fraction. All of this could be happened. So, in other words, we can say that probability represents the chance that one future test exceeds the threshold, might be. And we can go to the other thing here. Example to explain probability. A construction project tested the compressive strength. So we are testing the strength, one of the mechanical properties here, of 40 concrete cubes. So these are the total samples here. 40 concrete cubes are going to be tested. At 28 days, it was found that 12 of the cube had compressive strength greater than 37 Newton per millimeter square, which is 37 megapascal. Calculate the experimental probability. It's asking for probability here. That randomly selected concrete cube has a compressive strength greater than 37 megapascal. And we know that it was found that 12 of the cubes already above 37 megapascal. Out of what? Out of 40. So the event happened for 12 samples, and the total possible outcomes 40 here, which is the fourth number of samples. So you can write in this way: the probability here equal 12 over 40 give you 0.3, which would be 30%. So this what's called the probability here. And if we would like to predict future tests, so for previous one, we have already facts here. We already tested and we know what's happened. But if we would like to predict the future test, and this is what industry doing based on some factors they already tested and already sampled, they would like to predict what is the future test. And if we talk about predicting future test, we are going to use some models called binomial distribution. And what is a binomial distribution and how we calculate this? How to calculate the future tests here? In order to calculate binomial distribution, we need some parameters here. Number of trials, which n, named as n, and number of trials might be repeated tests. In the future, in the next tests, how many tests you are going to try in the future? For example, next 5 tests, next 10 tests, and something in the future here. And the probability that you already calculated for something already happened here for one trial, for example. So the first one, number of trials. This depends on the decision of the factory, for example, and the probability of success, which already calculated. And the previous example is number above 37 megapascal, which was 12, and previous example, divided by the total results, which was 40 at that time. So probability you already calculated, and number of success in those n trials. So this x will be explained later more clearly here, but usually x follows binomial distribution with parameters n and b, number of trials here, and b, the probability. Let's read this questions. A construction company is analyzing the compressive strength of concrete cubes at a batching plant. A sample of 35 concrete cubes is tested. So these all sample tested here. 35 concrete cubes is tested. And their compressive strengths are recorded. Using the sample data, estimate the probability. So I believe you can calculate the probability now that a cube selected at random has a compressive strength greater than 34 megapascal. And the question itself telling you the hint here, you are going to use in your answer, the number of cubes with strength greater than 34 megapascals are 13 samples. So 13 samples have already been showed that their compressive strength is above 34 megapascal. So this is the number of success. And the total of samples was 35. So from these values, 35, total 13 is the number already succeeded here to become above 34 megapascals. We can calculate the probability. And then the question move to another point. Assuming this probability remains constant, use binomial distribution here to calculate the probability that at least one of the next 6 cubes tested will have compressive strength greater than 34. So from previous knowledge here, we can get the probability, no problem. But here is telling you something in the future here. Will have a compressive strength greater than 34. And if we talk about the prediction in the future, or we should use binomial distribution, we're going to learn how to use binomial distribution here. So first of all, the question telling you that number of cubes greater than 34, this is the success here, are 13, and total number of divided by total number of cubes, which 35 will give you the probability. So you can get the probability, which would be 0.371. And what does it mean if we would like to translate this meaning here? This means there is approximately 37.1% chance that randomly selected cube exceeds the benchmark strength, which was 34 megapascal. And then look to binomial distribution. For binomial probability here for next tests in the future, we need to understand the probability. It's 0.371 that you calculated, and the number of trials. And number of trials in the question, if we back to the question here, telling you next 6 cube tested. So numbers are going to have 6 trials in the future. So these are called number of trials. That's mean here, number of trials equal 6. We have probability. So to succeed or to write binomial parameters here, we say x binomial by n. We write n and then p in this bracket. This is the way we express what we are going to use of parameters in order to calculate the binomial distribution. How to calculate? But before we go to calculation of binomial distribution for 6 trials and the probability, we have to look to this word. At least one of the next 6 cube tested will have a compressive string. So we need to calculate the binomial distribution at least. So if we have 6 trials, at least one of them should be greater than 34. Might be first trial, second trial, might be both of them, might be three. So a lot of options here. So at least one means the value of distribution for any one equal one, any succeeded trial equal one or bigger than one. So many possibilities here. This practically it doesn't make sense to try if it's one trial succeeded, both of them succeeded, or the second one succeeded but the first one didn't succeed. So it's a lot of hectic process. But there is another way. And instead of go to the probability of each one above for to get the value above 34 megapascal for the 6 trials, we can calculate for zero success. That's mean nothing will go to above 34 megapascal. This is called complement rule. Complement rule here say if you look to any success above 1, that's mean it's equal 1 takeaway failure here. If you remember at the beginning of this session, we mentioned that any success plus failure must equal 1. So in order to explain this about more carefully about complement rule, this is a nice figure to explain this. If you would like to go to the bus or the bus station or the bus company, say our buses always will come on time. Might be in 10 minutes or less, 12 minutes or less. If this happened with the bus, this is called success. So any if the bus arrive less or equal than 12 minutes, this is called success. But if it's arrive uh, greater than 12 minutes, which is 13 minutes or equal, this is called failure here. And we know that success plus failure must equal 1. So success here equal 1 takeaway failure. So if, for example, if the probability of this one 30% or zero point 0.3 and the probability become failure is 70%, you can see here they must equal 1. Or if you would like to calculate the success and you know the probability of the failure, you say success equal 1 takeaway failure, which 1 takeaway zero point 0.7, this will give you equal 0.3. So usually we rely on this relation, success plus failure equal 1. So if we back to our example here, which telling you that at least one of the next 6 cubes, and when I say at least, there are many possibilities here. Might be all 6 trials succeeded, might be 2 of them, 3 of them, 4 of them, 5 of them. So the easiest one, in order to calculate the binomial distribution, to calculate the failure, because the probability of the failure is 0 here. So probability become greater than or equal 1, equal 1 take away the failure. If none of them become exceed to 36 megapascal. So if x equals 0, that means no cubes exceeds the required mechanical properties, compressive strengths. That's why it's easy to calculate the failure here if it's equal 0. So how to do this one? Using Microsoft Excel or Google Sheets. It's quite straightforward process. Once you have your sheet ready, you write this is the columns here. You look, you write n and you write the number of trials. And then the probability that you already calculated 0.371. And the upper limit for continue, we know that upper limit is 0 because telling you we are going to calculate the failure now when x equals 0. We said x here, x, just to remind you here, x equals 0 here. So this is called the upper limit as we are going to calculate the failure now. So we write this x here equal 0 as you can see in this cell here. And then in this probability we're going to calculate the failure here. How to write the formula here? Go to the function and write find binomial distribution, or you can write manually here. You can write equal ben om this here. But if you just type bin in the search field of the function field, you'll get ben binomial test here. And then you open the bracket, you write 0, this one, or you can click to this cell. This is the upper limit for failure, and comma, number of trial, or you can click here, and then comma, and then you can click on probability, or you can write it, it's up to you, and then comma, and then write true. And you have to care there is a space between the comma and the number, comma, space here, and space there. If you write it in this way, it will be automatically calculate the binomial distribution for the failure here when equal 0. But the question didn't ask for the failure, it asked for at least 1. So we can say 1 take away failure. So here we write equal 1 take away this value, you can get the binomial distribution. So from this one, you can calculate it straightforward here and easy. Another example. Look to this one here. You have this data. Concrete cube compressive strengths were measured at 28 days for 30 cubes. So this is the total number here, 30 cube produced on construction site. The results are shown below. So these are the values here. And what's question asked? Calculate the mean compressive strengths, calculate the median, determine standard deviation, find the percentage of cubes that lie within plus minus 1 standard deviation of the mean, and then estimate the probability that a cube selected at random has strength greater than 36 megapascal, and then use binomial distribution to calculate the probability that at least one cube is the next 5 tests here. So if you have this data, it's quite straightforward. You can get the mean and the median from Microsoft Excel or Google Sheets. If you don't know, please watch my video number 3 to understand how to calculate the mean and the median and standard deviation as well, and also the percentage of cube lies that was within plus minus standard deviation of the mean. So from Google Sheets or from Microsoft Excel, you can get mean, median, standard deviation here, and I'm going to upload this data for you guys, named as example 2, and then also percentage with plus minus 1 standard deviation of the mean. It's quite a straightforward process. Once you get the mean, you add to the standard deviation to calculate the upper limit, and the lower limit, mean, take away, standard deviations, then you got the lower limit. So now you have upper limit, which this one is upper limit 38.86, this is upper, and 29.76, this is the lower. You need to count how many values between, including the upper limit and the lower limit, between the upper limit and the lower limit, in addition to the value in upper and lower limit, you will find from your data there are 18 cubes. So in order to calculate the percentage, we say 18 divided by the total number of cubes times 100 is equal 60%. So the percentage the example asking for 60%, and this have been showed in a previous video. Let's carry on which related to the current session here. Estimate the probability for compression strings greater than 36. In your data, you need to count how many samples showed results above 36. You will find that there are 11 samples showed properties or compressive strengths above 36. So 11 is succeeded event divided by total possible outcomes 30, which gave you the probability 0.367 here. So we have now the probability, which now we are responding to the example. But the last part of this example is asking about calculating binomial distribution here for the next 5 tests here. So we need to write binomial distribution in this way, succeeded, of what we are doing here, then this one number of trials, and then P here, the probability. And don't forget, it says at least one. So any one of the trial of the next 5 tests, they would like to calculate. And again, this is a hectic process to find the all possibilities for the 5 tests. So the either one, if it's at least, we calculate the failure, which none of them. None of them means x equals 0. None of them will exceed 36. It's easier to be calculated because we have a function to do so. So this is the success, which it's the question asking, equal 1, take away failure. And again, I need to remind you, this one have driven from success plus failure equal 1. So what we are going to do, what we have done, success became the subject, success equal, and we move failure to the other side with minus, so it's equal. You don't need to memorize this because it's become established, but I'm just telling you how we got this statement here. So success equal 1, take away failure. So success in these situations is the probability for at least one. So anything greater than 1, this is success, which is a question stated. 1, take away failure. Failure here is none of them will exceed 36 megapascals. So that means take away probability of x equal 0 here. So how to do this one? It's much easier to use Microsoft Excel to do it, and or Google Sheet to do it here. You are going to do in the same way that we have done before, and to double check your answer, you will get this one. As you can see, you will find the mean, median, standard deviation, percentage, probability, and binomial distribution for next 5 samples. The example data for this example will be uploaded. So if you have any questions, just contact me. Thank you.